Okay, see if you can find out the limit of this function here. I don't think you can do it, but have a go anyway, because you might have to use a trick that I haven't shown you yet. So try and find out the limit of this function. And when you plot the when you plot the graph here, it will look like this. So here you can see there's an asymptote here around here. If you ever want to know where this asymptote is, look at the function and try to make this to be 0. So when is this 0? Well, this is 0. Hang on. 2x to the power of 3 minus 1 equals 0 here. So add 1 to both sides. So that will give you this. And then divide by 2. So that will give you this. And then cube root both sides. That will give you this. Okay, hang on. Cube root both sides. And this value here is where the asymptote is. Okay, well, anyway, if you ever find, if you try and work out the limit of this function here at this asymptote here, it will give you it will give you a definite limit at the top, but then at the bottom it will be 0. So you're going to have a whole number. Well, you're going to have a number here and 0 at the bottom. So whenever you see this here, you can see that here you can say that the limit does not exist. Does not exist. That's for us trying to find out the limit, not at infinity, but at the asymptote here, at what was it, cube root of a half. If you try and find out if you try and find out the limit of this here at cube root a half, it will give you well, you can see here the limit doesn't exist. Okay, but I'm not asking that. I'm asking find the limit of this thing here as x approaches infinity. So you could sit there and put, let's say, 999 into here and then into here. But then why 999? Why not 9999999? Well, you could. Well, you need to develop a better way of finding out the limit of this rather than just plugging in a really big number. For all we know, 9999999 is not big enough. For all we know, this number here is not big enough. So we need to develop a way of finding out the limit of this as x approaches infinity. Now, looking at this graph, you might say, oh, it's heading towards 0 here, but don't just immediately assume that, because it could be something. It could head towards a limit of, let's say, 7 over, I don't know, 274. You see this here. This is not 0, but it may look like it on the graph because this number here is so small. My point is that the graph here, looking at the graph, you might guess it heads towards 0, but don't always jump to that assumption. Well, anyway, try to have a go. Find out the limit of this. See if you, I don't think you can do it, but try and develop a way of doing this. There is a trick to this. Okay, so find the limit of this. Press pause and think about it. I don't think you can do it, but have a go. Press pause and have a go. Okay, so the trick here, and you haven't been taught this, so divide everything by x to the power of 3. So looking at this bit here, hang on. So looking at this bit here, divide this bit by x to the power of 3, divide this by x to the power of 3, divide this by x to the power of 3, divide this by x. Well, basically divide everything by x to the power of 3. So if you do that here, this will be hang on, 5x divided by x to the power of 3. So that will be that would be it would be 5 over x squared. Okay, and then basically I'm just dividing top and bottom here by x to the power of 3. Okay, dividing top, because yeah, when you have a fraction, you're allowed to divide top and bottom by the same thing. Now looking at this here, 2 divided by x to the power of 3. Let's just leave it as that, x to the power of 3 here, and at the bottom I'm dividing. Don't forget, this here exists in a bubble. I know, but we can still divide that thing here by x to the power of 3. So you could argue, oh, it's in a bubble here. You can't just divide by x to the power of 3. Well, look at this here. I can now split these two up. So this whole thing here can be written as 2 to the power 3 over x to the power 3 minus 1 over, but you see, I can split the two up because a over b, take away c over b, that's the same as a take away c over b. So we are here, I'm just working backwards to do this. So basically, this here, I'm dividing this bit here by x to the power 3. So this would be 2, okay, because this thing here divided by x to the power 3 divided by x to the power 3, that would be the 2. And then this thing here, hang on, minus, well, I'm just going to leave this as 1 over x to the power of 3. Now, hang on, so let me put the limit in. So limit as x approaches infinity. You see, when you have a fraction like this here, you can actually say, well, as x, looking at this here, as x approaches infinity, this number here is going to be massive. It's going to be really big. So 5 divided by something that's really, really big, it's just going to give you 0, because 5 divided by this bit here, as x approaches infinity, is going to be massive. Okay, and then you got plus. Now looking at this here, as x approaches infinity, this number here is going to be massive. So you've got 2 divided by a massive number here. So that's going to be 0. So as x approaches infinity, this thing here will be 0. Okay, and then you've got 2. Looking at this here now. So you've got 2 take away. Now take away this thing here as x approaches infinity. That will be 0. So here you've got 2 take away 0, which is just 2. So here, so here this is allowed because you in effect have, don't forget the limit here is 0 over 2. You are allowed to have 0 over 2 because that is 0. 0, you can divide 0 by 2, but you can't divide 2 by 0. My point here is that 0 over 2 is 0. So after all, the limit of this whole thing here is actually 0. Okay, but you can't always assume that. But just by looking at the graph, the limit of this is actually 0. Okay, the trick here is to divide by the highest power here. Really, divide top and bottom here by x to the power of 3. You see, it's very useful when you have something like this, 5 over, let's say, x to the power of whatever, when you're evaluating as x tends to infinity, because this, by doing this here, this will be really big, and then making the whole thing very small, well, making the whole thing 0. But if you try and put infinity into this thing here, you're just going to have 5 times a really, really big number. It's going to be a really, really big number. And then you add 2. 2 is not that important when this here is really big. So you're going to have something like infinity, something really big. And then if you try and put infinity straight into it, well, as x tends to infinity, this is going to be massive. Times 2 is even going to be bigger than massive. And then you take away 1. Taking away 1 is not that important. But the point is, as x tends to infinity, this thing, you see, infinity over infinity is another indeterminate form, so you can't really deduce much from it. That's why the trick is to turn this into somehow 5 over x to the power of 2, or maybe 1 over x to the power of 3. You see, when it's in this form here, you can say that as x tends to infinity, this whole thing here will be 0. This whole thing here will be 0. Okay, so when you try and work out the limit of something like this, try to divide top and bottom by the highest. Well, anyway, okay.